That's awesome. Thank you. Okay, so this is the talk I'm doing now. If you'd looked earlier today, it would have been a different talk because I was planning to talk about something else, but in the end, it just wasn't working. It was a brand new talk, and I'd been asked to do it because if you may have seen the agenda earlier, I was going to be doing a talk with Grace Jensen about security in biology, and so you can imagine it all went terribly wrong. And so we're here talking about something that is still very important and very useful. So I'm going to talk about this thing. Who's heard of Log4Shell? Yes. And I'm going to take you through that, what it is, and we'll do a little demo in the middle, and then we'll talk about the consequences and other stuff, and maybe you get to ask some questions. Right, so. Okay, the reason that Log4Shell is here is because I work with an amazing guy called Ak Sharma, and he is a cyber researcher, journalist, and he always finds amazing vulnerabilities because that's what we do. And I said to him, why can't you find some Java problems? You're always doing Node stuff. All right, so that was on this day. Of course, you know, the next day we have Log4Shell, and suddenly I get my wish. And this thing turns up, and it grows. There's all sorts of information starting to float around. It gets on the TV. Java vulnerability gets on the TV, and it gets to the important people, and then it gets to the leaders of the political space, and it just keeps growing. Log4Shell may be the worst ever vulnerability, and that's not even saying a Java vulnerability. At the time, and I think we can still claim that given all its circumstances, it is still the most obviously exploitable, high impact vulnerability that we've ever had. There may be other ones out there that we don't know about, but this one, this is easy. And I'll show you how easy it is when we get down to the demo. And it got to this state of being horrific, and we're all going, what are we going to do about it? And then it got worse because people began to understand a bit more about how it was working, and they learned how to change data. So one of the things about Log4Shell that you have to take away is that Log4Shell is about exploiting the data that your application receives and the application logs. And I talk to people and they go, well, I don't have an internet-facing application, so it's okay. And I go, it's got nothing to do with the internet, it's to do with the data. So if you read a database and you log the records in that database, even if the application doing that isn't on the internet, if that database has the right type of data in, then they've got access to your system. And so what was happening here was that people were literally playing around with the names of their phones and the names of their Teslas to put in the bad characters, which we'll talk about later, so that they could actually trigger these vulnerabilities. Right? That's how easy it became. So wrong thing in the wrong place, wrong vulnerability, thing we haven't seen for a very long time. Before this we had struts. You may remember struts 2 back in 2017, I think it was, maybe earlier than that. Now, one thing to know about Log4Shell is that it turns out that the vulnerability isn't a new one. It turns out that the problem has been around since 2014. So it's not even one of these zero-day things you may hear about where somebody finds it, gets reported, people start exploiting it. No, the world has been telling the Java community since 2014 about some of the fundamental weaknesses in Log4j that could be exploited. So we have a fix for something that's, I don't know, quite a few years old. Okay, so I'm going to go through some of this. Depending on where we go and what questions get asked, we may do things faster or slower. We're going to talk about the whole space of Java exploits. I'm going to talk about mechanics specifically at Log4Shell, give you a demo, and then talk a bit more about the consequences and the things that you need to learn. Okay, so why Log4Shell? Well, Log4Shell lets bad guys achieve something that they really, really want to do. It's the primary driver for Log4Shell. Is the main objective is what's called arbitrary remote code execution. You may hear RCE or ARCE, and that literally says this is a gateway that allows the bad guys to run whatever code they want. Absolutely whatever they want to do. That's their main objective. Right? And whatever they do, steal your data, change your data, but that's the primary thing, is full access to your system. Imagine the conceptual thing is they can get access, they can log on, get a console on your system. That's what they're after, because obviously then they can do whatever they want. If they can't achieve that, arbitrary remote code execution, there are some other things they might just be able to get. They may not be able to run arbitrary code. They may be able to just run the code that you've got installed, the tools you've got installed. And even if they can't do that, maybe they'll try and steal your data or change your data. Every point of that access, every part of the system that's been compromised, there's always a value. It's just a matter of how much value it is. And unfortunately, Log4j was way on the end of best value ever, because you could run arbitrary code. And, as we'll show, it's invisible. Under the right circumstances, you won't even know that this has happened to you. Okay? So, another thing to think about is how this starts, right? And the other thing you have to understand about attacks is it's not human beings, it's bots, it's botnets. Millions of devices. And the way to think about it is imagine that there's a burglar, right? You're trying to break in, and he is literally going around every door and every window, every lock he can unlock in the building, the house, wherever you live, whatever building you can think of, wherever you in the world you are, all the time, 24/7. We have bots out there, and all they're trying to do is find a little way into your system. It's fully automated. Millions of systems doing that, probing your systems all the time. Now, once they get the first connection, once they get in and go, oh, actually, I know what you are, because they're looking for some hint as the type of system you are, and they'll do that within a few seconds. So basically, you turn up, you deploy your application to Amazon or something, you open the door, within seconds, one of these bots will be asking you some information. They'll be trying to figure out what you are. And then from that, they'll grow. The more information that you give them, the more refined the data attack can be, and generally they'll try things. And the way they try things is they're like reversing your APIs, driving it in different ways. There's all these things. This is called, well, you can't see read the red words, but in red it says fuzzing. Fuzzing is a term that means I'm going to try to use your API in ways that you weren't necessarily expecting. So if you say your API takes the numbers 1 to 10, I'll try -1 and 11 and int max and things like that. I'll try different verbs. If you've got using HTTP, I'll try the different verbs. I'll play with your API. Get that? And this is fully automated. Fuzzing is a technology that's been around for ages. It's a practice that's been around for ages. Look, long list that you can find on the internet. Go to the OWASP guys and they'll tell you all about it, how it works, what tools are out there that are pre-set up. So there's no human beings involved yet. This is all automated technologies built by people primarily designed to probe our systems, to help us discover our weaknesses, but now being exploited by the bad guys to get in there and steal your systems. Fully automated. Right? This says, with sophisticated tools. Shouldn't do red on black in a bright room. What I'm showing here are some of the extras that get added to this package. So you've got people who are trying to get into your system, bots trying to get into your system, using these tools, using these fuzzing capabilities, and it's very, very sophisticated. Right? The Artillery Fuzzer is a tool, a well-known tool for driving these fuzzing attacks. Zero wet space, that's an example of sending in data that you didn't even know existed. It's using Unicode, etc., in ways that your application may not even realize is valid. Big list of naughty words. Not what you think it is. Right? The big list of naughty words is the list of common things, terms, descriptions that you as a developer will use. So it may be application names, API names, all sorts of stuff. Like it can be the names of common passwords. There's all sorts of stuff. The point is, it's out there, fully available for people. So these bots have all the tools, all the capabilities, all the data they need to probe your system. Right? And it's not just your APIs, it's all your data. There are vulnerabilities in image parsing, there are vulnerabilities in security protocols. All these things get probed, right? Binary payloads, text payloads, you name it. If there's a vulnerability in there, if there's a weakness, if there's a way of driving that code, driving parsers in ways that weren't expected, they'll find it. It's a very sophisticated setup, right? Everything they need to drive these attacks on you or in automated ways, well crafted, everybody's doing this. And so that means that Log4Shell is a pretty good gift because they have all these fantastic tools for getting into your system, and Log4Shell is basically you leaving the door open, and they just got to find that door. Now the way it works plays on some weaknesses that we as human beings have, as with developers have, and I'll go through some of those things. So the first thing is, how does it work? Well, you've all got loggers. We all use loggers in some way. As a developer, especially if you deploy into a cloud service or something, you need diagnostic information. So your things go wrong, you want to be able to collect diagnostic information. So you use loggers. We all use those. These sorts of patterns, you know. And one of the things that we do is log data coming into our system. So in your log, you've got whatever the data is. Yeah. Whatever comes in, you log. So you make some requests. You go, I need to log headers. I need to log user IDs. I need to log key. I mean, whatever it is you're logging. You're logging it because you're trying to trace through the application path so that in the event of a failure, you take the log and you go back and you go, why did my code go this way? What does that mean? That means you log the data that you get given. Whatever data comes in, you log. Because if you were to change this data, you would not be able to debug it because you're now logging data that you didn't get. And about the only time that you might even think about not logging the data you've got is if you get passwords. Because we're aware of don't log passwords. Right? So, one, we're already decided that logging is about logging whatever we get, whatever data we come in, and that's cool. But the other side of logging is you want to know sometimes information that might be a bit more generic, a bit more flexible. Not just what the application's given you, but your environment. So if you've written an application that's you want to know what version of Java it's running on, or whether it's running on Windows or Linux or whatever, that might be important to you. So you log it. And so you could do system.getProperties java.version. You could do that, and that would work. But because we're developers, what happens is people go, well, why are you doing that? I can do that for you. I can do that in a more robust way. You don't have to do that. I can do this thing, log.info version $ open bracket sys : java.version. That says to log4j, when you get this string, do that. Go find out the data and put it in. So your log has whatever version you're running on, and whatever system property you need, whatever information you need. So we've got a situation where we're logging whatever data we get given, and now we have a process, what's called substitution parameters, that says if you give me certain strings, I'll expand them based on whatever I've got inside my system. Okay? So it's okay if you go, I've got system properties. Well, it's not okay, but it's understandable. And then you've got environmental variables. So you've got env on the front. You can even ask log4j about its configuration. And in fact, those substitution processes, as you can see, there's a long list of substitution processes that are available. And of course, it's Java, so you can write your own. So now the data that comes in can trigger substitution processes. Okay. So now we have this lovely position of accepting data in as is, giving it to the logger to report, and the logger reporting whatsoever is required. Okay, that's what you get. All right. But as you can see over this side, maybe you get a cookie in and you log the cookie and you get the data. But if the cookie is set to, hey, one of these special values, what gets logged? Not the cookie, but it gets expanded. So there is the core. Two parts. Our need to log the data that we get, and all these fantastic capabilities that log4j gives you to log whatever you ask it to do, and in nice, easy ways. Okay. So that would be bad enough. And then in 2014, it got so much worse, because in 2014, they put a request in, some people put a request in to add an extra lookup that was J and DI. The reason they asked for it is perfectly legitimate. What they wanted to do, just like they had with system properties, they wanted to be able to say, can you log some config data for me? Here is the place here's the path to the data that I want. System property name, or in this case, some J and DI paths. Because people have configs that run with, that gets, data, like JDBC databases, the config access is all, some people store them in J and DI. That's what it was for. So you had this capability added, and it's like, cool, we've added that, no problem at all, okay? Right. And the problem was that we added J and DI to give some capabilities, but it dragged in others, because nobody understood that J and DI itself had a process and an expansion and a plugin process. So that meant you could now start making requests to get config data from LDAP or MI or DNS calls. So I have this process now where I can part in this system parameter, this substitution process, and have access to almost enormous sets of data based on whatever the system's got. Access to LDAP servers, DNS servers, you name it. And that's pretty bad, isn't it? Right? But it gets even worse because it turns out that this process expansion is recursive. So if the data that contains a dollar or whatever gets expanded, if the result is also a valid substitution parameter, it'll get expanded again. You don't get two log entries, you get one log entry based on whatever the final answer is. Okay? So in this example, I've got an environmental variable called mode, which has a value of sys Java version, And then if I try to log and ask Log4j to give me the value of the environmental variable called a mode, it all substitutes itself and end up with 181 in this case. Okay? So there we go. So we have these amazingly powerful lookup processes for getting all sorts of data out of systems. We have a recursive substitution process, which I'll demonstrate in a minute as to why that turns out to be really bad. And this need, because it's a developer tool, to write the data as is. We do no validation of the data that we get in. Okay, so any data comes in that we log, whatever it says, Log4j will do. And as you can imagine, people started playing around with putting in data using these substitution parameters everywhere to try and figure out how to get into your system. Now, this is not about your application being internet facing. It's got nothing to do with that. It's to do with the data you log. It just so happens that quite often, well, we log cookies or access IDs and all sorts of stuff. But it's equally valid if the data that you're logging is a record in a database. Could be any of those things. Right. So who'd like to see a demo? Who'd like to see this in action? Yes? Yes, this is the fun bit. Right. I've got to find it now. That one. Yeah, okay. Right, so now I've got to figure out what I'm doing. Okay. Come on then. Is that coming up? Oh, it's a bit fuzzy. Okay. So, 9th of December, everything goes bang. And for next month, I'm trying to figure out what it's all about. And part of that, I create some demos and apps because I want to explore this. So this app, there's a little app in there which you can't see, which says to-dos, and you'll see some answers in a minute. Let's see if I can make it work so that you can see. Right, so now I've got to find my mouse. Okay, I can't see it. Anybody see my mouse? That's no good. I cannot see it. Oh, there it is. Okay. All right. Okay, this is going to be fun. Okay, how are we going to do this? Okay, this is going to be a short demo because I can't see anything. I'll tell you what I'm going to do. I'm going to do it on my side and then I'll shove it over so you can see. That might just work. Can we turn the lights off? Is that possible? I cannot see what I'm doing. Thank you. Does that make a difference? Not really. Okay, so. Right, there's that. Where's my mouse? Can you see my mouse? Oh, yeah. Okay, right. This is just going to be torture, isn't it? Okay, right. So, okay. So I'm going to type in, just so that you can see this. So I have this application that's called this is a to-do application, right? Oh, thank you. Right. So let's see what happens. I've got to keep my hand on the mouse. Okay. So it says, you can see in the middle of the left, sys.java.version. Okay. Right. So I'm just going to it's a to-do list. So I'd rather like buy milk, which I would demo, but we don't have the time. I would do this instead. I'm going to put in some data. Okay, now you can see the top right that says application consoles. So I've got various versions of Java I could select, and I've also got down here, if we go up, now I've lost the mouse. I've got a bunch. Oh, I've gone all quiet. That's better. So you can imagine I could play around with this stuff, right? Which we just do not have the time for, but it can be informative. So let me go back so I can see what the hell I'm doing. Okay. Right. So I'm going to pick a version of Java. Let's pick that one. Okay, and then let's see if we can see this working. Okay, right, so there we go. So it says system blah blah blah, and then I've got to find the enter button, and I go enter. Oh, that's wrong. Can't see it. Oh, I really can't see it. Oh. I may just do a text demo. I really want you to see this. Okay, bear with me. Okay. I wonder if I can do this half. Can I do this halfway? If I do that. Ah, that'll work. Oh, no, it won't. Okay, now I can't see that either. Okay. I'm going to skip this because I can see where this is going to go. But luckily, I have it in the slides to take you through it. And I'll see if I can help make it a bit more obvious if we do that way. Okay. Okay, let's go back there. Okay, so what you didn't see was a bunch of those exploits. Okay, but I have got them written down. Okay. So this sys.java.version thing you saw is easy. And you can imagine that comes in, and what happens is your log, so that comes in from the bad guys, they insert it however they manage to do it, so you log it, and you get that. And the Java version's interesting, because that tells them what version of Java running, and then they'll ask you about what class path you've got, because then they can figure out what code you've got running on your system. And the thing to understand is all they've got to do is get that data out somewhere. So currently, this particular example is going to get data logged to your log. So the class path ends up in the log. Who cares? It's your log. Right? Well, the problem is that everything can be compromised, and even your logs. So all it takes is the wrong configuration, and then your log is on Google because it's accessed. And in which case, they can read your logs. It's a mistake, right? You didn't intend to do it, but it happened. They exploited it. And like I showed you with the tools, there's a whole wonderful way of driving Google to find the stuff you want. It's not hard. Do you know Google could do these things? If you're really interested, there are these things called dorks, Google Dork descriptions. I have no idea why it's called dork, but literally it is a database of queries that you can put into Google to find compromised data. There are dorks of finding passwords, there are dorks of finding files, you name it. There's all sorts of ones. So here we are, index of it. Files containing juicy info, there's loads of them. Go have a look. Right? The point is that even the little vulnerabilities of being able to get your system to report data that you don't want to give out can be useful. And the other thing about the Log4j was we said about JNDI being added. JNDI dragged in LDAP. And LDAP, what happens is that the JNDI substitution process talks to LDAP and says, do this, gives us this URL. And this is just a made-up one, obviously. But what happens is it makes a call with LDAP. It does an LDAP call to a URL, and it logs whatever data it gets back. That's what it does. You can imagine that this information being parsed here, right, this is hard-coded. It doesn't have to be hard-coded. It could be a substitution parameter itself. So I could easily make a call. I could easily put this parameter in so that you log it, And as part of the logging call, I can say also another substitution parameter that says, tell me what the version is. And then a call gets made out to my LDAP server, and you give me my data. Okay? And I can then leak all the information I need. And at the very least, I now know that you've got a compromised server because you just told me. Because now I know that you exist. Because I made you talk to me. Okay. So there we go. I think I've just said this, but look, you can see I can make a call and I can pass in. So that first white line is the first line comes in, cn equals version. Yes, so this one comes in from the bad guys, however they get into your logging system. Okay, and so you trigger it. Your LDAP, your logging system says, okay, I've got to do that. I'll make a call to LDAP. So I make a call out to the bad guy server. The bad guy server sends me back a string. And that string looks like the second line. And that string includes, tell me what version you've got. And so the logging system sends that data back. Okay? And that can come back with all sorts of information. I've now got a communication mechanism because of this recursive process with the substitution parameters, where if I get one, I keep expanding it. And Log4j is doing that under the covers. That's the call that comes in. Whatever happens between then and now, the only thing that gets logged is the very last piece of data. This conversation is unrecorded. The only way that you would know is if you happen to be looking at the calls out to remote servers. And believe me, it's not going to be as simple as making 50 calls to the same server. Botnet, remember? It'll be different IP addresses, different URLs, hidden, so you won't spot it. That's what's going on. Now, this is bad enough, but there's a thing called a gadget chain. So these LDAP servers return strings, but they can also return Java objects. So I can actually make a call out to a server and get back code that can be executed. You said right at the beginning about the bad guys trying to execute code on your system. The LDAP mechanism is designed to return Java objects. And that Java object will get expanded, and whatever the two-string result is what gets logged. But as part of the expansion, because it's serialized form, code can get executed. Bad things can happen. At the very simplest version, it's just going to try and make use of whatever you've got on the class path, which you've already told it because it asked you previously to tell me what your class path was. So I have all the data I need to send you back a really simple gadget chain so I can exploit it. Right? And gadget chains can be complicated. They can be maps, they can be hash tables, you name it. There's all sorts of ways they could get data back to you. And it's all about serialization. I'm now into all that realm of badness that I can have with Java serialization. Right. Okay. Let's move on from that because I'm going to give you the chance to answer questions. Gadget chains can break your system because the serialized form of data that I get back can be of the form where it can ask for objects of massive size because it's serialization. So all that happens is the serialized data comes up and the JVM goes, oh, it looks, I need to create an array of 1 billion objects. Okay, done that. Use a load of memory. First object, oh, okay, it's an array of 1 billion objects. I've done that. A bit later on, out of memory. So imagine how you feel if all I have to do is make a call to your server with a particular substitution process parameter, and that causes your system to crash because of this. That's happening. Right. Let's move on from that. And then, the best one of all is arbitrary remote code execution, because the object that comes back, and this is a JNDI LDAP thing, the object that comes back in the right circumstances, so it's the right version of Java, okay, can be what's called a reference object, standard Java thing. And a reference object says, by the way, any code I want, any code that I depend on, comes from this URL. So I get back an object that says, here's the first object to instantiate, and any code this depends on, download it from this place. That means completely arbitrary execution. I can run whatever code I want if you have the wrong version of Log4j and the wrong version of Java. Okay? Yeah. So these RCEs, you just need an object that has this object factory, and it doesn't even have to exist on your system. That's the horrible thing. It exists on the bad guy system. It comes in, and JVM goes, oh, it's one of those. I know what to do. I have now in this mode of loading remote code. And this all happens under the covers because of that substitution process happening inside Log4j and not being visible. So I can have very complicated calls, pass data backwards and forwards, run whatever I want, install malware, steal your data, change your data, that easily. You just have to be in the right space, the right configuration for that to happen. Okay, I think I've done that. Yeah. Yeah. Now, it turns out that some people thought they were not vulnerable because they did some tests. And it turns out that Log4j has this checkered history from 2.0 onwards. And depending on which version of Log4j you've got, you may or may not be subject to some of these attacks. Not sometimes because the feature wasn't added yet, you have an early version of Log4j, but if you have a later version, there were some bugs that meant some of this code failed. So you're lucky. But then it got fixed. So then you upgraded to the next version and suddenly, you're vulnerable. The takeaway from that is just another example that whenever you're looking at these situations, you can't rely on your safety being just because it doesn't fail now. Because you can upgrade one of your dependencies could upgrade one, right? Any of that could happen, and suddenly you're vulnerable again. So always in these complicated situations, or where you have very dangerous CVEs like Log4j, you have to go to the latest version. You absolutely have to go to the latest version. It's the safest thing you can do. Even if you think you're not vulnerable, you probably will be. Right, so I want to move on a little bit. I think I mentioned you can't see the red, yeah. So what I was going to show you, because this is how I was going to end the demo, was this, going back again, just to reinforce, data comes into the system somewhere, it's at the right format, you log it, Log4j parses it, and it kicks off this process because it makes a call out to remote server. And then a conversation takes place, and then eventually there'll be some final thing that comes back, and that's what gets logged. And it'll be innocuous. It won't be, thank you for your data, but it will be something simple. And then it's gone. You have absolutely no idea that that's taken place. So Log4j is not only dangerous, vicious, it's easy to exploit. They can run really bad code, and you will never know. And let's just go to the last bit. If that's bad enough, I said about moving to the latest versions. Well, we're not. This is a snapshot from Sonatype's So I work for Sonotype, if that wasn't clear. We run Maven Central, and we keep track of the downloads. And you can see when it first came out, the Log4Shell vulnerability was pronounced, that everybody updated. Lots and lots of updates. Great. But not 100%. And right now, whatever number you look at, you can go look at live data now, we're in that number. 30, 40% of people are using vulnerable versions of Log4j. And when I say people, I mean code. Somebody's downloading these, and it's part of some other thing. And it could easily be a dependency that you're using. Because as we've realized, the tools that you use to find out whether you're vulnerable are not all equal. There are many tools out there. Some of them will figure out that you've got a Log4j problem. Others won't. So if there's one other takeaway from all of this, is that you need to go back and look at the tools that you've got and ask yourself, is this actually able to find my Log4j dependencies? You can't rely on it anymore. You have to go test it. It's not particularly hard to write some test case to see whether your tools do what they're supposed to do, but people tend to take the tools at their on face value. So, or they may go, I'm using Dependabot, and Dependabot won't help, because Dependabot only finds the top level dependencies, the dependencies of your application. It won't find the Log4j that's 3 dependencies deep. That's what it's not for, it's not designed for. Right? So you need to go back and have a really good look at how you manage dependencies and what tools you use to find them, and make sure they actually can find these vulnerabilities, because currently 40% of us sitting in this room who think they're safe aren't safe. Right, I think, given I have 2 minutes 55 on that clock, I will stop there. Any questions? Anybody going, I need to go home and patch my server? There's a question at the back.
Yeah. So we have this big vulnerability since 2014.
Yep.
With these big and other researchers trying to find, and in Insight it's a easy one to exploit. So how do we have 7 years and nobody raises a flag?
Well, yeah, okay. So it was raised, but it wasn't raised. It was raised. A lot of the black hat communities spotted the vulnerability potential and reported it, as in told the Java community this is a problem. It never got fixed. And do you know why it didn't get fixed? Primarily because it wasn't seen as a bug. It was seen as a feature. And this has been added for people, for your use. Right? Now, and I don't know whether I interrupted you, but the other thing to think about is just think about what you said. This thing has been there since 2014. It's readily exploitable. So what's the correlation? It means it's been exploited, right? And there is evidence turning up now that says, yep, this has been used. And we've got amazing evidence of Log4Shell being used to add malware to firmware that ends up in your routers. You name it. It's a wonderful way in, and it's been exploited. The only real difference between 2014 and now is the scale of attacks have grown. In 2014, we still had, I wouldn't say under control, but it was still mostly a commercial activity. Hacking was for money. But what's happened very recently, and you would have seen this in some of the situations happening in like the Ukraine, where the realization is that this isn't just good for hacking for money, it's also a wonderful way of inserting malware into some other person's supply chain. and to find ways to compromise or be prepared to compromise the supply chains of your country. And so now what we're seeing, this is why this is even more important than ever, that this isn't just a vehicle for getting people to bring ransomware into your system, which is bad enough, but also targeting you because you're part of a supply chain. We're all part of a supply chain, right? And they're trying to get into your supply chain to hide controlling software so that at the time that they need to, they can disrupt your systems, bring trains to a halt, stop food being delivered to supermarkets. That's the objective. Not necessarily to be triggered now, but to be triggered when necessary. Yeah, scary, isn't it? Okay. Do I have time for some more? Yeah. Any more? No?
Thank you. Just a small question. As I understand, the main vulnerability was in the GNDI module. I mean, if someone has an old version of Log4J, is it good enough mitigation just to ban the affected module, the GNDI module? I mean, I think it's a library.
Well, in theory, yes, because people have been saying one of the ways you can hack this was to go into all the jar files of your system, find the root JNDI class and kill it. And you can do that, but what happens the next time you do a build and you pull down the updated version of it? So you can do that, you can hack it, and some people did, because it was seen as being the best temporary compromise. But it's not a long-term solution. And just to rub it all in, that particular class being spotted as being a wonderful tool, people started taking it out and using it in other packages. So apparently, I haven't gone looking too much, there are other open source projects out there that also have that sort of capability, the LDAP capability, built in because it was useful. And we're also seeing it being used also by the bad guys because, again, it's another little way of getting data onto your system. Because one of the things about malware delivery is it's a very staged process. They get the smallest piece in first and then grow. So the JNDI class has been used in a few places for that sort of stuff. Now, if you thought you were leaving JNation and you were going to be happy, I hope that I've made sure that you're not, right? What can I say? It's a bad place. We are in this bad place. It is happening now. And a few years ago, it was bad but not horrific. But now, because of the fact that the bad actors are doing things for different reasons, and that has now become mainstream, this sort of problem isn't going to go away. We're going to get more of it. And even more scarily, this one got reported eventually. We have lots of evidence that says the ones that turn out, the new vulnerabilities that turn out to be very lucrative, very useful, won't get reported. Because actually the people who are finding this are being paid off not to report things. And not trivial amounts of money, many millions of dollars. Because you can imagine that the person who, if this had been a brand new one and somebody had found it, and then they didn't report it, but it was used by state actors, so think of how valuable that would be to them. Right? So you have to take that. And the other thing to remember is you are all part of a supply chain. Right? We all provide services, whether it's software services or something else to somebody else. We consume them. We know people. We're all potential targets in this new modern attack surface because of who we know and what we do. So it's not about banks, it's not about finances, it's about the fact that, I don't know, you produce leather goods and you sell those leather goods to the military that keeps the trousers up. You know, there's all these connections that they're looking for because each one of those could be disrupted and it affects both your economy and your ability to act as a nation. And that's the new reality. That's where we're going. Right. So there you are. Thank you so much for listening. There's another talk, isn't there? Oh, we're doing another Jeopardy. For those of you who missed it, we're going to try and squeak in another one in a few minutes. If you're interested in coming along and throwing rocks, if you're a speaker here, you should come and participate. No excuses. Yeah. Other than that, thank you very much.